Okay, welcome back. And here's the second part of our lecture on ADC, shorter than the first one. Okay, so the ADC, we want to be able to rate the software. And as we've mentioned, there's two sets of approaches, or two approaches we want to take. One, manual, when in the code we just make a single or several different measurements of voltage, and the auto, which collects a whole bunch of samples for us. So if your signal is changing quickly, auto is the best one. But if it's reasonably constant, then you want to use the manual approach. The big function is this guy, Open ADC 10. That's where you configure everything that you need to make this work properly. Read ADC is where you get the voltage measurements back. Okay. Close ADC should be obvious. Enable, after you configure it, this actually starts the module working, collecting data. We mentioned that there's buffers and that ADC writes the values it records to buffers, and they're temporary, then we always had to read them. So this is for reading the buffers. In manual, we pick what channels we're using and say start, right, acquire the signal and then convert it. And this is a little thing that tells us to wait until ADC is finished doing its conversion. Now the big program, or big function, is Open ADC, and it's got 1, 2, 3, 4, 5 parameters in there, each of which are reasonably complicated. There's many variations on how you could collect data using ADC. We're going to only look at the manual and the fully automatic modes. So there are other things you can do, but we're not going to do that. We want to keep this lecture nice and simple, and the code we do fairly straightforward. Okay, now to make things easier, when we do Open ADC, the configurations are so long, we actually separate them into a bunch of headings that were parameters 1, 2, 3, 4, and 5. So we're going to change these and just call the program or the function like this. That'll make things work. Always before you run ADC, the manuals recommend that you close it, clear all the settings to the default settings so that any choices you leave out aren't affected by any previous calls to ADC. Enable ADC turns the module on. So we're going to be talking about all these parameters. Parameter 1. So in the textbook, I've tried to simplify all of these things and have left a few out and only mentioned the ones we're going to be interested in. And I've mentioned whether we use them for automatic mode or manual mode. And you can see in this first parameter, we turn the module off at the start. And it's recommended that you only turn it on, enable, when you're at finished. And so for this, we only had to choose whether we're doing manual or automatic. So a complicated parameter has been simplified. Parameter 2. Well, this is a bunch of things we kind of know about already. Whether we want to use a VDD and VSS, the internal voltages, as our references, whether we want to use VREF plus and VREF minus, or decide one of them is a reference and the other is whatever. Okay? So we'll typically use this guy, but we might use external if we need more precision. Scanning is what the automatic mode does, so if you're in manual, that's off. The number of samples you take will typically be 1 in manual mode, but if you have 4 pins you want to sample in auto mode, X would be 4. If you're in the manual mode, you want to use the 2 buffers of 8. Right? And in manual mode, you can use 1 buffer length 16 because it doesn't matter, you're so slow collecting data. So the first setup back here, this setup, the voltage reference, again refers to all the possible settings here. Right? So if we want to use VDD as our reference setting or VSS, or some voltages in between, the different settings we can have. Okay? Remember, if you've used a VREF plus and a VREF minus, right, 0 refers to VREF minus and 1023 is VREF plus. Any voltages outside that are either 0 or 1023. And when you're using the reference voltages, you don't get to use AN0 or AN1. Here are the 2 buffers, right? So when it's off, we're using just 1 buffer of 16. When it's on, we've got 2 separate buffers, right? So even though it's called buffer A and buffer B, really it's the same buffer A. It's just where in buffer A data gets added first. So they're still numbered according to these 16 places. Parameter 3, we're always going to use the peripheral bus for timing. These 2 are for how much time it takes to do the conversion. If the signal in manual, it doesn't much matter. It'll be fast enough, basically any values we set. Right? In automatic, you have to be more careful with these 2 choices because you want to sample fast enough to get all the features in the varying signal. So here's how the calculations go. Right? X, the setting right, up here, the conversion clock select can be any number between 0 and 127, and the timing constant is a multiple of the peripheral bus clock. Right? So for us at 8 megahertz, TPB is 1 over 8 million. So you select just this guy. Right? So if X is 0, you're 2 TPB. If you're 127, then this is 256 times TPB. The sample time Y is the delay between sampling and the automatic conversion, so the sampling time. Okay, so T sample is that guy times T add. So this is the timing setup. This tells you how long you're going to sample for. Conversion, right, that high-low game always takes 12 TAD. And the total time for ADC is T-conv, conversion, plus T-sample time, okay, which will give you this. Right? You have to make sure that your TAD is always greater than 200 nanoseconds for manual sampling and greater than 65 nanoseconds when you're doing really fast ADC. Generally, you're not going to have to worry too much about those numbers. The final parameters are the simplest ones, right? These are the pins, A and X, that you're going to use to collect the samples. Okay? So X can be 0 to 5, 9 to 12. If we wanted to use pin 0 and 9, it would be enable AN0, ANA, and then OR, and enable AN9, ANA. This one, config scan, is a little strange. In manual mode, you're asking for multiple channels, you don't say scan the 3 channels I want. You say skip scan, you skip or do not scan all the other channels. In manual mode, you just say don't scan any of them. This can be a little annoying, as we'll see a little later. So here's my manual operation code. Okay? The ones we're going to concentrate on, right, that you'd ever have to worry about, is changing this guy, because you might need to use external references. And down here, you have to say which pins were being used. We're going to just use, in this example, 4 and 5. But if you wanted 0 and 9, 0, 9. Okay? So that's all you would do in the manual mode. Sorry. Here's the example code. Once you've configured, as on the previous page, right, you have to use set channel to pick up which channel you want to do. Everything else doesn't change, except the print message, of course. You can print whatever you want. Okay? So what's going on is you're saying, I want to sample from AN4. Acquire ADC starts the RC sample and hold circuit working. We wait for that to finish, and then we start the conversion using the high-low algorithm. That takes time, so we wait around for that to finish, and then we record the result. Because we're doing just one channel at a time, our value is in the buffer, the first position. So this is a setup where we then do a different pin and read its value. Automatic mode is similar. Okay, so we could change the reference voltages if we want. We can change the sample and hold sampling time. We can change that TAD parameter that I called X before. The thing that's a little different down here is parameter 5. To make things simple, instead of listing all the channels to skip, I've got skip scan all, and then this is exclusive OR this guy, exclusive OR this way. And this simply says skip them all except AN4 and AN5. Otherwise, we would have to rate them all out. And this is a little simpler to do. Okay. The text recommends a small delay after you start up ADC to let things settle down. But pretty much that's it. Those are the two, so that's how you configure automatic. And then inside the code, you have something like this. This is collecting 2,000 measurements. Remember, auto mode, you want to collect a lot of values typically. So in a for loop, you see which buffer is being written to. So if this is equal to 1, that means the buffer is being read, the B buffer is being read. Okay? So you can read things from the A buffer. We're reading 2, so this would have AN4 and AN5. Okay? Then you wait around until the next one is active, right? And so if we're reading from A, then the next time this would be true. And notice you're reading from 8 and 9. The first two elements of B are the 8th and 9th of the entire buffer. And this just prints out the results. And I'll show you some examples of that code in 1 second. Okay, so I've called up MPLAB, and here's the manual ADC. So from the samples I had on those previous pages, I've built some code up. So parameters 1 through 3 are calculated. You see I'm using sample time 10 and x equals 1, so we could calculate how long that is. But since we're doing manual, we don't really care about these numbers as long as we stay in the rate limits. I'm using AN4 and AN5. And this is how I would sample. All the code just like we said before. Let's look at what the output of this program looks like. Reset. You can see it sampling as we go. Right? The two readings are a little bit of time apart, but it's longer for the for loop than how long they take to do. So I'm just having it on a little voltage divider board, so it's not moving around until I take one and switch it. Right. So I can get different readings out of these. So I'm just moving this around a little voltage divider board. Okay, so that's the manual. We essentially just need to have a copy of that whenever we want to set up for manual ADC. Next, we'll look at the automatic. So here's the automatic code. Right? So one of the things I wanted was something to actually measure, and I don't have a good voltage source. So what I've done here is I've used 2 pins to output a square wave. And so we're going to use the ADC module to look at 2 PWM signals from the same board. Not how you would normally use this. You usually have some external signal to measure, but this is convenient for us. Here are all the parameters set up for auto mode. Okay. Looks mostly like what we had before. I've chosen a certain sample time and value of x to calculate to determine what my sampling time is. And down here, I have a for loop to collect 1,000 measurements. Actually, 1,000 measurements times 2, because it's 2 channels I'm using. So 2,000 measurements. It's running before I do this sample. It's running after I do this sample. Okay, so that's just sampling from the continuous ADC. In here, right, I'm seeing which buffer is active, so I read from the other buffer and put the results into permanent memory. And then when I finish, I just print them out. So I've got this loaded and running already. So it's finished, so I'll start again. And you can see all the data's collected. 1,000 times 2, 2,000 data points. Now, that's not very interesting to you. And so normally what you want to do if you have that much data is to plot it. And here's the data. I've moved it over into an Excel spreadsheet. And this Excel spreadsheet, this is the which ones I'm measuring, and these are the voltage measurements. They're either high or low because I'm using a square wave. If I look at chart 1, this is one of the square waves I put out which had a small duty cycle and here's the second one. Okay? So the one thing about the pick is we're getting all that data, but getting it to a screen to see it is quite difficult. Right? We'd have to collect all that data, and I'm not sure we could get PuTTY to do some sort of graphical display. Might be possible if you play around with it well. But this is it. Putting the data into Excel takes a bit of work. You've got to collect all the data from PuTTY. You just go copy all to the clipboard. You have to save it in Word, save it to a text file. You have to have Excel read that text file, and you have to separate it out into columns, and then you get to plot it. So it's a lot of work to do that, but it's doable. It'd be nice to automate that sometime. Anyway, that's ADC. So we have two pieces of code, one for manual operation, one for automatic operation, that we can use anytime we need. That's it.